Now we shall start our exposition with one example. So in this example, we will be starting with a problem which is faced by many scientists. Suppose I have a number of molecules. So here I have one molecule, here I have another molecule, and here I have another molecule. I say that these molecules consist of two types of atoms. I have the red atoms and I have the blue atoms. Now I want to measure the masses of these two types of atoms. So what can I do? I can take the atoms separately and weigh them. That is pretty difficult, but they are only available as compounds, so I can measure a molecule of a compound. Then I can try to solve a system of linear equation. So in this case, I suppose measure the weights or the masses of all these molecules, and I get, so I have to do some kind of an experiment to do that, and as a result I get some numbers. Suppose the numbers turn out to be like this. So I measured one molecule of this type, I got 9.8, whatever unit. For these I got 9.1, and for these I got 7.0. From this I want to find out what are the masses of the two types of atoms. Now that should not be very difficult, so let's see the first molecule. Here how many do I have? I have red 1, 2 and 3, so there are 3 red things. Suppose each of them has got mass A, and how many blue type? 4, so 4 of type blue. So if I just try to make an equation out of it, I will get the equation 3A plus 4B equals that measured 9.8. Similarly, for this one, I have how many red? 4 red and 1 blue, that is 4A plus B. I do have 4A plus B, that is equal to the 9.1, and in this case I will have 2A plus 3B, 2 red and 3 blue. So I have got these things. So I have got 3 equations in 2 unknowns. Now I know that if I really want to solve it, it's enough to take any 2. So but I have these 3 measurements. So you might be tempted to try to solve all these 3 equations to get A and B. That is, try to get values of A and B which will satisfy all the 3 equations. If you give it a try, then you will find that this system of equation happens to be inconsistent. You cannot find values for A and B, no real values of A and B for which all these 3 things will hold simultaneously. But how is that possible? The reason is all these things are actually approximate. These numbers, this 9.8 or this 9.1 or this 7.0, these are all approximate quantities. They are result of measurements. So ideally what I should have said is that these are approximate. I have changed my equalities to approximate equalities. Now the point is, well, approximate or not approximate, how do I really solve this? I just now notice that if I ignore the approximation and treat them as exact equality, then I just cannot solve it. But that is how life is. You never get measurements which are exact. Then what do I do? Well, you might be tempted to say that, well, ignore any one of them. Just solve the other. Suppose I take the first one and the second one and solve them, treat them as exact. True, but remember that there is some amount of error involved here, So the values that you get will be not exact. However, this equation, this third approximate equation, also gave you some information. Now, why did you throw this thing out and keep these? I could have thrown this one out and kept these two. I could have thrown this one and that one. I could have just thrown away this one and kept this one and that one. In each case, you will get different answers. Which one should you choose? All these things actually give you information. Throwing away any of them is not a good idea, and even if you decide to throw away, how do you choose which one to throw away? So throwing away is not good. What we want to do is, we want to take all these things into account. I hope you understand that even in this artificial example, we have given you a situation that is faced by all working scientists. You have some theory. The theory predicts that you should see this, then you measure it, and the measurements are all some amount of a little bit of random, there is some random measurement error. So the equation that you will get will always be or almost always be inconsistent. There must be some way by which you are able to solve an inconsistent system of equation. And that is exactly what linear models do. It's a way of solving inconsistent system of equation, or something that we should more precisely call approximately consistent system of equation. And this will take us to some fascinating application of linear algebra.